In this video, we will discuss the magnification. With optical devices such as lenses or mirrors, we can create images that are bigger or larger or that have the same size as the object. And we have already discussed that the images can also be inverted compared to the direction of the object. In fact, we define a quantity called the lateral magnification as the ratio of the lateral size of the image, y prime, divided by the lateral size of the object, y. And we have already seen an example of inverted image by a convex lens or a concave mirror. And in this case, y prime and y are in opposite direction, so m is negative. And we have also seen examples of non-inverted images by a concave mirror in a different situation or by a flat mirror. And in this case, y prime and y are in the same direction and m is positive. And in fact, the lateral magnification for any optical device can be obtained by this formula. You see that for a flat mirror or a flat refractor, the magnification is 1. So the size of the image is the same as the size of the object. But for other optical devices, it can be different than 1, depending on the position of the object, the image, and so on. And so I am sure that you know the interest of having a magnification larger than 1, right? We want to produce larger images so that we can see better. Right? So one method is to use a concave mirror with a large radius of curvature. And if the object is very close to the mirror compared to the center of curvature, then the image, which is represented by the arrow with the letter y prime, will be larger than the object. And so in this case, the magnification is larger than 1. This is used to produce magnified images, for example, the mirror used by the dentist or the cosmetic mirror. Those are concave mirrors that have a very large radius of curvature so that the object is typically quite close and produces an image that is not only larger, but it's also upright, right? It's not inverted. But we can also create upright images that are smaller. For example, if you take a convex mirror with a large object represented by the black arrow here, and then the image can be smaller than the object, and the magnification in this case will be smaller than 1. But so what's the point of creating a smaller image? Well, often we will want to create smaller images to get a wider view, right? So that kind of convex mirrors are used in stores, for example, to see a wide view of aisles of the stores on the mirror. Or you can see this on street intersections to be able to see the other cars coming. The image is smaller, but then you have a wider view. By the way, if instead of a car you see me in the mirror, then just say hi, right? And then send me a picture. So in fact, have you ever noticed that on the passenger side of your mirror on your car, it says objects in the mirror are closer than they appear, right? What is this? Well, it turns out it's physics 9b again. Right? In fact, the passenger side mirror is a convex mirror. And the reason is because the driver is quite far from the passenger side mirror, and so the view is quite narrow. And using a convex mirror, then we can get a wider view. Right? But at the same time, because it's a wider view, it also makes the image smaller. And so the objects look smaller, and we believe that they are far. But in fact, they are closer than you think.